students. Yesterday, no, I take that back. Last week we studied weather. And I mentioned to you last week that we would be extending this whole lesson into this week's topic, which is climate, because weather and climate very closely related to one another. So we are going to be continuing this week with the topic we call climate. So make sure your books are open to the appropriate place, and we are going to start plowing ahead with our notes on the topic of climate. So let's begin with a little definition of what climate is, or at least how we are going to define it in this class. Climate can be described as the general weather. And after last week's topic, we know exactly what weather is, the various condition of the Earth's atmosphere in a given place at a given point in time. But climate can be described as the general weather over an area or in an area over a long period of time. So basically the difference, one major difference between weather and climate is weather is the condition of the atmosphere in a given place right now. Right now, if you look out the window, right now you can see what the weather is. Climate is the general weather over a long period of time. And yesterday you saw some videos describing weather, including some controversies over things like climate change. And we're going to be exploring that throughout this week. So let's continue with this idea of climate, general area or general weather in an area over a long period of time. During the course of this week, we're going to describe climate in terms of two things, the temperature and precipitation. So during the course of our period today, we are going to be describing climate in terms of these two things, temperature and precipitation. And this is going to take the bulk of our period today, because we are going to be talking about various factors that will affect temperature and precipitation. By the way, if you look in the background of this slide, if I were to ask you, what kind of climate does this picture describe? What might you say? It's a desert, right? Well, that word itself is a description of a climate, a dry environment, usually hot and dry during the day. That would describe temperature and precipitation over a long period of time, which again is climate. So let's begin with temperature. There are three factors that can affect the temperature in an area over a long period of time. And so let's talk about these three factors affecting temperature one at a time. Number one is the latitude. Now, last unit we learned about geography around planet Earth, and we learned about latitude and longitude, and you know that latitude is the distance above or below the equator, north and south of the equator. Now, if you look at this diagram here, we can get a better sense of how latitude affects the temperature in an area over a certain period of time. And we could illustrate with this globe here too, although the diagram, I think, illustrates it very well. But the sun, which is 150 million kilometers away from us, produces sun rays, rays of light. And unlike this diagram, the rays of light that hit the Earth are pretty much parallel to one another because we are so far away from it. This diagram is slightly exaggerated to show or illustrate the point that at the equator of the Earth, the sun's rays are hitting directly, meaning at about a 90-degree angle. And equatorial regions of our planet, they receive the most intense rays of light. Whereas near the poles, near the North Pole or the South Pole, the rays that strike our planet are acute, meaning a shallower angle. And so there's not as much heat energy received at the poles. So the result of that simply is this: it's hot at the equator and cold at the poles. Just ask a polar bear and ask what would be an organism that lives at the equator? I don't know. Uh, uh, I can't. I'm drawing a blank with my brain right now, but ask a tropical animal and ask a polar animal to describe their environment in terms of temperature. At the tropics and near the equator, it's hot. You go to the poles, it's cold. And the reason for that is because of its latitude away north or south of the equator. So, again, another illustration here. At 0 degrees, which is at the equator, it's going to be hot. We divide Earth's latitude to 90 degrees north and 90 degrees south of the equator. And at 90 degrees north of the equator, that's the North Pole, it's cold where Santa lives. If you go to 90 degrees south of the equator, that's where the penguins live, and it's cold down there too. But near the equator, it's hot. Between 30 and 60 degrees, we call that the mid latitudes. That's where we live, and that's where we experience the greatest changes in weather over the course of a year. So we have a different kind of a climate. So here's the basic result of latitude. You can be writing this in your notes. At the equator, the climate, generally speaking, is hot and moist year round. It's hot and moist. At about 30 degrees latitude, and we'll see the reason for this a little bit later on as well, but about 30 degrees latitude, there are very dry climates. At 60 degrees latitude, we have moist climates. And finally, at 90 degrees latitude at the poles, it is very cold. So these words that we're using are words that describe temperature and precipitation, because those are the key words when we talk about climate, temperature, and precipitation. All right, the second factor that can affect the temperature of an area is elevation. Elevation. By the way, if any of you ever ridden in an elevator goes up and down. Elevation is up and down relative to sea level on planet Earth. So elevation, first of all, describes the distance from the surface. The higher you go in the atmosphere, the higher the elevation. In fact, right here in our own township where we live, we can see this difference this time of year in the wintertime. It's not uncommon that in the valley, in the lower regions of our township, it might be raining. And if you look up at the mountains in our area, you can see that it can be snowing or is icy as you go higher in elevation, because it doesn't take that high in difference, that big a difference in elevation for the temperature to really drop and make some major changes. For instance, I'll give you one quick example here. This could be showing Mount Kilimanjaro. Mount Kilimanjaro is a tallest mountain in Africa, and it's located near the equator. At the base of the mountain, my goodness, it's tropical, it's hot, but it's got snow year round. on the top of the mountain because of the difference in elevation. Because the higher you go, the colder it gets. It gets colder the higher you go. In fact, I was just listening to the weather report a month or two ago, and there was something interesting that happened in Hawaii. Hawaii is a tropical island. It's located in the Pacific Ocean, and it has a tropical environment, generally speaking, a tropical climate year round. However, depending on where you go on the island, the climate is different. There is a mountain on the big island of Hawaii that had a blizzard about a month ago. Yeah, a blizzard, a whiteout condition. Generally, you don't think of blizzards associated with Hawaii, a tropical island, but because of the difference in elevation, those mountains are high enough that it can be pretty cold. And of course, that will affect the temperature and consequently the climate of that area as well. So, elevation, here's a picture of a mountain. At the bottom of the mountain, it's going to be generally warmer, and at the top of the mountain, it's going to be generally colder. And that's why when little kids draw mountains, or even adults for that matter, we usually draw a mountain with white at the top because it's not uncommon that tall mountains will have snow caps on the top of them. All right, the third factor that can affect temperature are the ocean currents. Ocean currents. Now, how do ocean currents affect climate of land? Well, it basically has to do with the distance of an area away from the coast. That's right. In fact, right here in our own state of New Jersey, for instance, if you watch weather reports often enough, you will notice that regions that are near the coast typically have temperatures that don't fluctuate as much. The further inland you go, the temperatures fluctuate a lot more. And what do I mean by the word fluctuate? I mean changes between highs and lows. So as you continue to watch weather reports this week, pay attention to how the temperature changes or fluctuates even on a daily basis, areas that are near the coast and areas that are further inland. And when you're talking about continental areas, the fluctuation is even more extreme. Take North America, for instance. Wow, the Midwest. Coldest temperatures in our country have been recorded in the interior parts of the continent. If you go to the Midwest, North, South Dakota, Minnesota, those regions there, wowie kazowie. They can get really, really hot during the summer and super extraordinarily cold during the winter. Why? Because you can't get much farther away from the ocean than the Great Plains in the middle of our country. You're like dead center away from the Pacific Ocean or the Atlantic Ocean, and you get wild fluctuations in temperature. So here's an illustration of what I'm talking about. Near the coast, and that's either the eastern or the western coast. If you're near the coast, temperatures will be more moderate. If you're on the interior of a continent or large landmass, the temperatures are going to be more extreme. So coastal temperatures are more moderate, interior temperatures are more extreme. And the example that I gave you of the Midwest of the United States, great example, but you can apply that example to any continent on the planet pretty much. Go to Europe and Asia, Africa. Temperatures are much more extreme all the time during the within the interior of a continent, and near the coast, it's more moderate. Moderate means it doesn't fluctuate nearly as much. So in your notes, you could be writing that ocean currents is a factor that affects temperature in that more extreme changes occur farther from the coast. Okay, so extreme changes take place farther from the coast. So if you don't like wild fluctuations in your temperature, live near the coast and you won't have as extreme a change. All right, there's also, let me just add to that a little bit because it also does depend on the compass direction, the coordinate of your location. In other words, on west coasts of continents, and we'll just take North America for an instance, but on the west coast, notice the color of this arrow. The ocean currents on west coasts, in the northern hemisphere at least, are typically cooler because you're coming from the poles. And on the East Coast, they're typically warmer because of the currents coming up from the equator. So, again, let's just think of North America, the United States, as an example. Here in our state of New Jersey, if you go swimming in the middle of summer, the ocean temperatures are going to be warm enough that you can swim with a bathing suit and without a wetsuit and be perfectly comfortable swimming all day long because we live on the East Coast and the ocean currents are coming up from the equator. Namely, it's the Gulf of Mexico that they come up. The Gulf Stream current is what brings warm water from tropical regions up the East Coast. On the West Coast, however, like California, Washington, Oregon, I don't think I would find it comfortable swimming in a bathing suit without a wetsuit on at the same latitude as New Jersey because the ocean currents are polar currents coming down from the pole. So on the western side of a continent, the ocean waters are going to be cooler. And so that's going to affect the climate in an area as well. And so our last note under this category can be that the west coast is cooler, the east coast is warmer. And again, we're talking generally speaking over a longer period of time. Generally speaking, over a longer period of time, these are the trends dealing with temperature, the three factors affecting temperature: the latitude, the elevation, and the proximity to ocean currents. So we're about halfway done with our notes for today because right now we're going to continue with three factors affecting precipitation. So, precipitation, we learned all about different kinds of precipitation last week. Precipitation here incorporates all of those different types. Ooh, so first factor, again, latitude. We're familiar with that already. Latitude affects precipitation as well. And we talked earlier about how latitude affects temperature. That was pretty straightforward and easy to figure out, I think. But latitude affects vertical airflow. What in the world does that mean? Well, let me show you a picture here which will illustrate it, I think, a lot better. So near the equator, and think of the principles we learned last week, last topic, regarding weather, wind, and how air flows. Near the equator, we got the direct rays of sun that are heating up the surface of the earth a lot more. So hot air rises. That hot air is going to bring with it a lot more moisture. But as it goes higher in the atmosphere, a higher altitude or elevation is going to start cooling down and then it's going to sink. And as it sinks, all the moisture will have already been taken out of it and it's going to be drier. And these, what are called Convection currents, these air cycles, continue in different regions of our planet. We touched on this a little bit in the last topic. And because of these circulating, vertical circulating uh, currents of air, at the surface, we experience it in a different way. If we're between 0 and 30 degrees north latitude, winds are primarily out of the east, and we call those regions the easterly trade winds. From the 30 to 60 degree north latitude, the winds are primarily out of the west. We call those the westerlies, and above that, we have the polar easterlies. Let's think about this diagram as we jot a few things down in our notes, starting with the lower latitudes. 0 to 60 degrees latitude, either north or south of the equator, it's going to be wetter. At 30 degrees and 90 degrees latitude, both north or south of the equator, it's going to be drier. So if you look at a map of the Earth, and I'll show you one in class, when we look at a map of the Earth, the wettest climates on the planet are generally located around 0 degrees and 60 degrees latitude. The tropical rainforests of the Earth, located near the equator, 0 degrees. Our planet's only temperate rainforest, a wet environment, is located around 60 degrees north latitude. Our deserts of the planet, however, like the Sahara Desert in the northern hemisphere, the Kalahari Desert in the southern hemisphere, these areas are located generally near 30 degrees latitude, north or south. And the poles, believe it or not, North Pole, South Pole, despite the fact that they're covered in ice and snow, are very dry climates. They're desert-like climates, and they're located at 90 degrees north and south of the equator. Number two, a factor affecting precipitation is the land mass. And by that I mean the influence of the ocean currents we talked about with temperature also affect precipitation. So the land mass is a factor affecting precipitation because of ocean currents. Let me show you what I mean. Again, refer to our little map here. Here's the interior of a land mass. Here's a coastal region of the land mass. And generally speaking, it's going to be wetter near the coast and drier near the interior. So if you've got a really large land mass, well, like a continent, it's going to be wetter near the coast and it's going to be drier in the interior of that continent. And that is pretty much true. If you look at climate regions around planet Earth, that's the trend. It's going to be wetter near the coast and drier near the interior. So near the coast is wetter, near the interior, it's drier. And again, keep in mind, this is in terms of climate, which is in an area over a longer period of time. The weather near the coast might be wet one day and dry the next day. Likewise with the interior. But we're talking about climate this week, and it's the general trend over a longer period of time. All right, that brings us to our third and final factor here affecting precipitation, which are mountains. Now, the way a mountain affects precipitation is dependent upon which side of the mountain you are on. In one of the previous slides, we showed you how the wind direction changes in climate anyway, changes from one latitude to another. Here in the mid-latitudes, in the majority of the United States, we are in the westerlies wind region, which means the wind is usually coming from the west to the east. Now, if you put a mountain in the way, depending on which side of the mountain you are, that's going to affect the climate. let me show you this diagram. So here we have a mountain in the middle. If the wind is blowing from, we'll say, the left side of the mountain, if we're looking in the northern hemisphere from the south, this would be the west, this would be the east, but it's dependent on which way the wind is blowing. So we call the side of the mountain that the wind is blowing on the windward side of the mountain. The opposite side of the mountain, where the wind is blowing away from, we call that the leeward side of the mountain. So here we have the windward, here we have the leeward side of the mountain. Well, remember the impact that altitude has on both temperature and precipitation. So if the wind is coming from this direction, it's the windward side of the mountain. It can't go through the mountain. It's going to go up and over the mountain. And as it does that, the air mass is going to be rising. And as it rises, it's going to cool. And as it cools, condensation will take place and it will start raining or snowing or whatever the precipitation might be. As all that moisture is taken out of the air mass and comes down the other side, well, it's going to be a lot drier. Now, if we think of the Rocky Mountains, for example, in our country, the windward, the western side of the mountains, are generally going to be cooler and wetter because of that moving air mass. As it comes down on the other side, we've got the Great Basin, the area on the eastern side or the leeward side of the mountains is almost desert-like. We've got a warmer and drier air mass. So the way that affects climate over a longer period of time is simply this. The windward side of a mountain is generally wetter and cooler. The leeward side of a mountain is generally drier and warmer. Now, we have gone through a lot of information today. That's a lot to absorb, so feel free to watch this again if you want. Review your notes and study these notes because a lot of this information is going to be necessary for you to refer back to and understand when we get to our lab activity later this week. But for now, let me just say bye-bye.